Hello, this is going to be a demo video showing the graphing of data in a spreadsheet and finding the equation of the line. I'm going to start from scratch here just to kind of show you guys how things start out. Generally, the way it's phrased is graph something versus something else. In that case, the something that we're graphing versus something else is our y variable, and the something else that we're graphing it is x. Now, the standard in science is that you have your x variable being your independent variable that you are arbitrarily changing it. And in our bungee jumping lab, that would be the number of rubber bands we're using. But in this particular lab, they tell you to graph the number of bands as a y variable. Now that's particularly for your benefit and ease when you do the algebra on this. It's going to be easier because what you want to find is the number of bands, and the standard format of the line is y equals. So if you make your bands your y variable, this is just going to pop out really easy for you at the end. So I put x and y up there. This is also your default format if you're going to make a t-table, and also the format that your spreadsheet program, both Sheets or Excel or whatever you're using, what it expects to see. So you put your x variable on the left and your y variable on the right, and that's also how you would, like if I was going to graph it on the board and I was going to draw a t-table, this is the same thing that I would do. Now, your bands are your y variable in this case, which like I said is reversed from the regular, and generally we go every 2. Now, I can tell you the spreadsheet is kind of magical. It knows what you're doing. If you highlight like this, you see this little blue box in the corner. If you drag, it can fill for you. Now, I don't remember how much data we have for the online version. In the class, it's limited by the height of the room of the classroom, so we don't really have that much data. So we're actually going to delete some of these. We're not going to need that many. But that's just a demo of what the spreadsheet can do. Now, this is not going to be the same as your data. I'm going to make something up just to show what we're doing here. And also we do need to label these. I put the x and the y variable up there just to illustrate to you which is which. But we do need labels for our data, and this will automatically be used by the spreadsheet when your graph is created. So we want to say, what is this? So the number of bands right there. We start with 2, we drop, we find how far it goes. So this would be the drop height over here. So let's just say, for sake of argument, that for 2 rubber bands, you get a drop height of 35. That would be centimeters. So let's do this in meters. That's always the kind of better default. So if we have 0.35 meters, how about we have 0.75 meters? Yeah, that's not quite what we would want though. Sorry, let's do 0.65. Let's do 0.95, 1.25, and 1.55. Now you can see how very quickly you wouldn't be able to fit under the ceiling of the classroom, which is only like 2 meters-ish, less than 3 meters. All right, so now to create a graph from this, it's nice because your spreadsheet wants to help you as much as possible. You literally just highlight your data, including the headings of the columns, and you push insert, you choose chart. Now it will try to guess for you which kind of chart you want. Sometimes it's right, sometimes it's not. You can see over here that it chose a scatter chart. Occasionally, if it's confused, it will give you a bar graph, which is not what you want. But if you get something that doesn't look right, oftentimes if you just change it right over here, it will do what you want. Now, part of the thing that we're trying to do is extrapolate here, meaning we had a few rubber bands and a few drops in the classroom under the ceiling. But if we were doing this in real life, we would go out to the balcony that's 5 meters tall. So we want to know what happens at 5 meters. So we're going to have to go find our axes and we're going to have to change the maximum. So this makes a bigger graph that we can see. Now our horizontal axis we know is going to go out to 5.1 meters. And the online version, I'm not sure if they stuck with that or they changed it a little bit, but you can adapt this to your particular circumstances. Now you can see as soon as we did that, it changed the graph. So now it's going up steeply. So we know that we want the whole line up to 5.1 meters on the graph. So that means that we also need to change our y-axis. And literally, I don't even know where this is, but I'm just going to hunt around for it until I can find it. The vertical axis, well, we don't actually know exactly what number we want here, but we can just start putting numbers in until it looks like the whole line would be on our graph. So you can see there that the graph is big enough that if we draw a line that goes out to cover the height of 5 meters, we will also have the number of bands on the y-axis that's visible for what we want. So those are the two changes that you need to make on your graph. Now, the other thing that we want to do is we want to display a trend line. That's a little trickier, but you see that it's under the series tab in this chart editor. And if you go down under the format data point, the trend line is a box that you can check. And you can see all of a sudden that line is on our graph. Now that we've done that, we can see that, oh, maybe our line doesn't quite fit as far as we want. So if we, just a moment, we're going to go back and change the Y to be a little bit bigger so that the whole line is on our graph. Now, under label right here, you see right now it says none, but we can also choose use equation. And then you see over here on this graph, the equation pops up and we can see what the equation of the line is. Now, your lab guides you through the math that you would need to calculate each component. But if you look at this equation, this matches y equals mx plus b. So this number in front of the x is your m, that's your slope. And this number off the end, you see it has a leading negative in this case, it may or may not on yours. This number off the end is b. So if your lab says calculate b, you just say from computer and you write this number on it. If the line says calculate M and then there's multiple spots, you do not need to get all those numbers into those spots. You just take this number right here, you say from my graph, you will need to include your graph in your submission. You say here is M. And that's what all the lab is asking you to do. Now, we can go back to our axes, to our vertical axis, and we can change our vertical axis just a little bit bigger. Now, if we solve, what we want, our goal in this lab, is to find the total number of bands that will get us the drop height of 5.1. And like I said, this is kind of the real world version. They might change things a little bit for our online version. What we would do here is we would go down to the drop height, whatever it is, and for this example, I'm using 5.1. You go up to here, and then you read across your graph over here to where your bands would be. That would be your answer. However, we've got the equation here, and your lab asks you to solve the equation. So literally, you put your height, our height is our x variable, you plug it in for x, the height that you want to use in your final test, your final drop. We put 5.1 in there for meters. We multiply it by your m, your slope, whatever that is. You add b. If it's a negative, that means it's the same as subtracting b, right? But you just add the whole value of b, whether it's positive or negative. That will give you a number exactly, and it should correspond with your graph. When you get this, if you eyeball it, you see it's some number kind of under 35. Do the math, though. That's going to give you a lot more precision, and we expect to see that precision in the number that you submit. So that should be a quick little demo. You guys have seen it done. You've seen where the menus are and things. This is on Google Docs because that is freely available to everyone. You can do a similar thing on Microsoft Excel. Their menus are just a little different. You might have to Google to find out exactly where all the menus are and where the options are that you want to use, but it works very similarly. Whichever one is easiest for you or the skill will be most useful to you is the one that I encourage you to use. Thank you.